Welcome back to part 3. In the previous video, we left off with the knowledge of how to define custom types. At the end of that video, we had added a function to our custom type, but we had only declared that the function existed. We didn't explain the work that the function would perform. In this video, we are going to explain how to describe the work that a function will perform. Our topic is implementation. The function in question is the member function inside of our person object, void run. It's this guy right here. Let's look at the basic pattern for function implementations using our run function as the example. As with everything that we've already covered, we begin with the type declaration. In this example, it is void, and it is saying that this function will return a void value, aka it will return nothing. Next, we see person run. Now we see person : run. Now person : run is the full qualified name of the function. Where does this come from? The function run lives inside of our type. The type, in this case person, owns this particular function. So when we go to implement the definition of the function, we have to include the name of the owning type followed by 2 colons and then the name of the function. So this right here, this is the full name. Next, we see the same list of function parameters that we saw in the definition. Int how fast, and then bool start with left foot. Again, the same pattern. Here's the type and the name. Now, this list of parameters never changes between the declaration of the function. That's this right here. This is the declaration. And the definition of the function. That's this right here. I will add a star to this idea, like a little footnote thing, because you may have noticed over here that our definition for paint is slightly different than the actual implementation. And I'll explain that in a separate video. The next thing that we see is our opening brace and a closing brace. These braces tell us where the implementation begins and ends. So since this is an implementation and not a definition, there's no semicolon at the end. So remember, if you're declaring something that exists, you add a semicolon at the end. In case, like this line right here, we're declaring an integer with the name of age. We're declaring a function that returns void and takes 2 arguments. Okay, these are declarations. If you're defining a type, you also add a semicolon. So right here we defined the type person, and that's why it ends with semicolon. Like that. If you're defining a function like this, you don't add the semicolon. So just remember that a declaration is different from a definition. Just because you declared that something exists does not mean that you have defined its properties or the work that it is supposed to do. And I'll come back to this idea when we take another look at our person object's definition. Right. We call the stuff that sits inside of the braces the body of the function. It is inside this body that you're going to modify variables, you're going to use those variables, and you're going to call other functions. As an example of this, when our person runs, their distance traveled will change. Now, how can we express this idea? Well, we might have a member variable in our object that is called distance traveled, and it might have a type of int. So distance traveled, this is our variable, and it'll be of type int. And whenever we run, this value is updated with the size of each step that we take. Now, if you remember back to our first video, where we covered nouns and verbs, the equals sign and the plus sign are functions in their own right. So even if we have a line like this, you can break this down into the addition function and the assignment function. So here's the addition, right? Here's the assignment. So the addition function and the assignment function. Calling the assignment function right here results in modifying the distance traveled member variable on our instance of person. That's modifying this variable. I will get into how you determine which one of these is being modified in a later video. All right, let's look at what our run function might actually do. Looking at the second function parameter, we can use an if statement to decide what to do when the left foot is the starting foot or if the right foot is the starting foot. We can express that like this. Okay. I'm going to change this font size a little bit. Now let's look at this if statement. Both if and else are keywords. Okay, so we'll color those guys appropriately. You can think of if parentheses like a function that returns a value. And the value that it returns is either true or false. It accepts a single argument, and that argument is a true or false expression. So here's a super simple example. If true, do stuff inside the braces. Else, do different stuff. Okay? Now you remember that the braces indicates the body of the function. As we showed in the previous video, how you could have object definitions inside of other objects. Like here we've got our Hello World class, and then inside of that we have our main window class. That's a nested object. We can do that same idea with functions. Here we can have function bodies inside of other functions. These are referred to as blocks of code. Sometimes they have names, which is what a function is. This is a named block of code. And other times they don't have names, which is how the if statement works. This is essentially an anonymous block of code. Right? We can't call it specifically. There's no way to just randomly, in the middle of some other function, call this chunk. Call the code that goes in here. There's no way to do that unless we actually give it a name and turn it into a function. Let's dive a little bit deeper into the actual if statement and the single argument that it takes. This expression right here. If you remember from the first video, we had the plus symbol, and that's a function that takes 2 arguments and returns 1 value. And the return value is the summed value of the 2 passed in arguments. We can continue that same idea and say that this equals symbol is a function that takes 2 arguments and returns 1 value. In this case, the 2 arguments are what is on the left-hand side, and the right-hand side of the 2 equal signs. And the return value is whether or not these 2 things have an equal value. So this whole line right here can be looked at as first quote calling the operator equals comparison function with the 2 arguments. Start with left foot as the first argument and true as the second argument. They are compared to see if they are equal. That result is returned, and then the if block is called with that returned value. The returned value from calling our if statement, calling our if function, determines whether or not we run this or if we run this chunk of code. Okay, does that make sense? Let me break that down one more time. So first you get the result of this, okay? Then you call if result of this function like that, get result of, and then based on that result, decide which block of code to execute. I'm going to get further into this idea of calling functions like addition, assignment, Boolean comparison, etc. later on, as it's one of the most powerful features of C++. This was the addition function. This is the assignment function. This is the Boolean comparison function right here. Now they have different names, but I think for the purpose of where we are with our learning, these are appropriate names. It's mainly about knowing their function. Don't just think of it as like it's a plus sign, it's an equal sign. It has a specific job that it has to do. So that's why we call it the addition function, the assignment function. Usually with the assignment function, you're assigning whatever's on the right-hand side to whatever's on the left-hand side. Just adding a little bit of clarification. Continuing on, Inside the if-else blocks, let's express what should happen. Okay? So if we are starting with the left foot forward, we might say something like this. Then you add in your distance traveled. And you do it again for the right foot. If we're starting with the right foot, then we would just reverse the order of these two. And then add these guys together, like that. Now, a very strong concept that is super important in programming is don't repeat yourself. DRY. You'll notice that we are doing the distance traveled equals twice. We've got it once here and then again here. Okay, the usage is identical. So we can move these lines out of the function and put it at the end. Okay? These functions just got a little bit shorter. We also have distance traveled being used twice in each line, right here and here. Functions like the assignment function, the addition function, or the comparison function are called operators. And we can use a special operator called the addition assignment operator to shorten our code even further. Okay, and we can just do this, plus equals, like that. Now what this does, well, I'll leave this line here. Remember the assignment operator, so whatever is over here, it evaluates this expression and then stores it in this object's state here. So in our case, we're adding this value with this, getting a temporary value, and assigning that temporary value here. So we can do that all in one step by calling this addition assignment function. Okay. Now, this is great because our code is getting even shorter. We're still using distance traveled in two places, so we can combine that into an even shorter line. If we get rid of this and do that, now the first thing we do is evaluate this, take that as a temporary value, then add that to this value here, and then assign that back in. First thing we do is add left foot step size and right foot step size together. Okay. Then the next thing we do is add result of 1 distance traveled. Assign result of 2 to distance traveled. That's what this expression does. First it adds these guys together, then it adds that to here, and then it assigns it. It's shorthand for this, okay? This is shorthand for this. Cool, so this is what our run function looks like. All right, let's go through this and we'll do what we did in the first video where we identified the nouns and the verbs, or the objects and the actions, okay? Do you remember the syntax? We've got our object name, then a dot, and then the name of the action, okay? So our function calls, we will mark them with green. This is the first one right here. Now remember, this is not a function call, this is a function definition. We're not actually calling run, we're just explaining what it is. That's why this is in red and it's not in green. Okay, continuing on, here is another function, green, also green. Okay, this is also a function here. This is also a function, and this is also a function. Now, where are the nouns? Where are the objects being used? This is an object. This is a keyword, but we'll consider it an object because it is holding a value. It's a special named type. Left foot and right foot, these guys are names. Okay, so again, we've got our names, everything in red, these are all names of things. Everything in this purplish color, this is a type. Okay, everything in green, this is a function, right? It's some action is being performed. And everything else, these things in blue are just keywords. All right, so to recap, first thing we did was we talked about the basic pattern that you use for function implementations. First, you start with your type, then you start with your full qualified name, followed by the arguments that you used in your function definition. Then you do a curly brace indicating the start of the function body. Then you do a closing curly brace indicating the end of the function body. And then we covered why do we write person run. It's because the run function is special to this person type. So when we specify the full name, we have to include that it's part of the person object definition. Okay. Then we discussed what our if statement does and how it behaves like a special function that it behaves like a function that takes one argument and returns whether or not you're supposed to do this or if you're supposed to do this. Okay. Then we talked about the DRY, don't repeat yourself concept. And we were able to consolidate basically the code we had here. It was inside each of these blocks and we were able to move it outside because it was identical. It was being used in both places. Okay, and then the last thing we discussed was this this addition assignment operator. Okay. Okay, let's take a look at our main content component and see if we can identify this pattern anywhere. Okay. We'll go to main component.cpp, and you'll notice right off the bat, here we have a function. Okay. Here's the type that the function returns. All right. Remember, here's our declaration. Okay. This is where we declare that there's a function named paint on here, and then it takes the graphics reference and it returns a void. Okay. So here's where this actually is. All right. Here's the return type of it. Here's the full qualified name. If you remember that this function paint right here lives inside of our main component. And that's why the name is spelled this way. Here's the argument list right here. It just takes one argument, a graphics object. Okay. And then here is the work that is being performed. Okay. Now, if we look at the next one down, void resized, that's right here. There's our return type of void. Here's the full qualified name. You'll notice it has no arguments, and you'll notice that there's no actual work being done in the body of this function. It just has some comments. I haven't explained comments, but basically just do, you can either do 2 of these slashes, or you can write comments this way. If you do slash star, star slash, this is a block comment. Okay. Whereas the other way, this is single line comments, like that. All right. Okay, so we have identified full qualified functions, or function implementations. In the next video, I'm going to explain some more shorthand tricks that C++ has for us as programmers, which allows us to write this code in an even more concise manner. Okay? So we'll continue our journey in the next video.